So please ask questions to the panel. And Joe, you want to start?
Thank you all for the great talks. And one thing I was really struck by was the fact that even though data science is a fairly new term and still, some controversies over what it actually means, is that we saw a lot of common themes between the talks. There's also a selection bias there since, Hans-Peter, Pavlos, and I decided to invite you. But I was still very happy to see kind of a unified sense of what the field means or should mean, and a lot of common ideas on what the data science process should look like. So my question is, how do you see that process evolving, and in particular, how do you see data science? How would you predict that data science as a field will evolve, and how would you like to see it evolve?
Me.
Don't answer all at once.
Well, I'll just repeat what I said in part of my talk, which I just think many exciting. Obviously, there's a lot of activity happening across different pieces that come together in data science. I think by nature, many data scientists tend to be bricoleurs. One, in terms of methods, whether that's certain machine learning methods or visual methods, but also I think unfortunately at the low level, bricoleurs with lots of different programming tools and environments. And so I think one is I think people are embracing those skills, but I also think they'll be streamlined. And I think across the different components that we tend to work with, whether that's data preparation, modeling, visualization, this is where I'm repeating myself, I think better integration, really not just in terms of one tool A can talk to tool B, which is still really important, but really more deeper fundamental rethinkings of how these things weave together into a really effective process is something that we can continue to improve.
I also think there needs to be more emphasis on the very early stage of the process, which is deeper thinking about why you're analyzing the data in the first place. Not just, I'm going to manipulate this data into a way I can analyze it with the machine learning algorithms I know, but why are you doing that? Because are you using it to make decisions? Are you using it just to get insight? Are you using it for prediction? Because that's going to drive a lot of the decisions that are made throughout the process.
And, this is a question that we've struggled a lot. The process that led to the creation of this institute at Berkeley was a year-long internal process where the entire PI team had to kind of wrestle with this question. Even with the question, do we even call this thing data science? Because I think that in and of itself is an open question. We decided just to give up on that acronym and just move on with the fact that it's become somewhat accepted as a term. But I guess the approach that we're taking is that we're considering this to be an experiment. We really want to come in with very few preconceived notions, other than the fact that we realize that there's a problem in collaboration in academia, that there's a problem with the incentive structure of academia, which tends to focus on very discrete, highly visible events such as high visibility papers or large grants and whatnot, being at odds with the process that we're seeing in all of these tools, which is a very fluid process of collaborative knowledge creation. All the projects we talked about here are on GitHub, and there are these very fluid processes. And so what we're trying to ask is, well, how can we create an environment where the research, the scientific research component is there, but the educational component is there, and the creation of tools is also there. We have teams that are very anchored in tools like the IPython project and the AMP lab machinery from our CS department. How can we create an environment for those ideas to try to build something different, recognizing that the conditions are changing, and we're trying to be very flexible, and that is reflected in the layout of our space and how we're designing the new areas of the library, because I don't think, honestly, we know yet what this is going to look like. And we know we may fail, and we probably will make a lot of mistakes, but we're sort of okay with that.
I would add, in addition to what my colleagues said, that sort of this distinction between skill sets and technical skills, but then also process and the way of thinking, and trying to train people in how we think end to end, and how people from other disciplines think. And so it's an appreciation, I think, of process and thinking, and not just technical tools and skills. So I think, at least from the point of view of education, getting that sort of more emphasized in education.
Question?
Thank you. I see there is still a relatively large gap, though, between good analysts and then getting people to be good consumers of our work. And it's very hard to find the whole package of someone who understands the analysis and research design and statistics and can then help people draw conclusions. And Bonnie, you kind of hit on this, I think. There's people who open the New York Times and look at the visualizations that are there, and they have a data artist who it instantly clicks with them, and other people who are never going to get there. What do you see in training for data scientists to start to bridge this gap and help people tell the story so that people are good consumers of our work and it doesn't just get stymied?
So I'll take that one first, since I teach a visualization class, and so we're dealing with typically 20-something-year-old students, and I tell them when they come into class, you may be surprised at first because this is going to be like reading and writing, and you've spent decades learning to read, write, and do math, but very few of you have actually been trained in thinking about communicating information visually. And they say whatever, and then by day 4 or 5, they're like, "You're totally right." And so, but it's actually, but at the same time, the alacrity and the quickness with which they can take to it is also really promising. And I think it doesn't require a lot of education, but it does require some education. I think doing that hand in hand with basic quantitative skills as well is incredibly important. So I think there's a clear educational mission there as well. I also think that there's something to be said, to the larger issues that you're pointing out in terms of like making the results of these analysis valuable to the people downstream. Part of that's an issue of collaboration. Part of that is like the right level of common ground. And you may be like a holy grail that's unattainable, but for me, in some sense, data science, as at least the research field, is most successful if it puts itself out of business, in the sense that the people who have the data and have a driving question, to the degree to which they're able to service it themselves, as opposed to relying on a data science expert to do it for them. As much as we can move in that direction, we won't get there fully for a variety of reasons, but I think that's an important area to push towards.
I also think there's sort of an element that we can learn from journalism and journalists here and how they tell stories and investigate and ask questions, and then how they find what's actually interesting to other people, but also that sort of doesn't mislead them, that sort of tries to give some sort of objective truth in the data. And I think it's important in communicating about data to try to communicate what is subjective, what's objective, is there any such thing as objectivity in it, making sure you're transparent about the data collection process and your modeling process. But I think, yeah, again, it always goes back to education.
So I have a question.
I actually want to follow up on Rachel and the idea of journalism. And obviously this is biased from the perspective of IPython, but one thing that we've seen recently was actually from the Wall Street Journal. There's a data researcher who works in the back end of the Wall Street Journal who built a tool based on IPython where he could write notebooks with the code and the data analysis, preparation, graphics, and results that then from which he then automatically generated reports for the journalists to then write the final narrative that would go to the public. So these notebooks are not quite public-facing. They're internal in the Wall Street Journal process, but they basically allow the narrative that goes to the public to be very closely coupled to an intermediate narrative that contains code and data, and where the journalists can go back and ask new questions, and they can iterate very fluidly and collaborate on the data analysis part. Similarly, at the New York Times, the team that uses Mike Bostock's tools built the Kepler visualization, the Kepler Astronomy Exoplanet Search Visualization tool was written with the back-end data analysis being done also with IPython notebooks that did all the data preparation for the final infographic that was there. And what we're hoping to see in the future is that these tools, these notebooks that can combine code and data actually do make it eventually to the public, so that if I, as a reader, want to explore whether the data analysis was done right or whether that discussion about budgetary or fiscal issues really has statistical finagling, that I could not just read the narrative of the journals, but actually grab the underlying computation and play with it. And I think that might lead to a more informed debate around computational issues at the journalistic endpoint.
I'd like to ask the panel a question. I'm up here at the top back here. I'd like to ask the panel a question about what versus why. The history of science has been that science has been theory-driven and proven by experiments, and now with the amazing successes of big data and massive volumes of data, the world is being encouraged to be data-driven. But when we use things like machine learning and other analytical techniques, we focus on the what. That a virus is spreading out of North Carolina or something, versus why. And so I'd like to have the panelists comment on perhaps the role of the human, the data scientist, in the process to determine if the what is really significant. Like in Jeff's diagrams, I was looking at them, and like the lady said, I said, gee, that's really cool, but what does it mean? So the question is, as we become increasingly more data-driven and focusing on what, we seem to be less interested in why. That is, why are these things happening, which in medicine may be long-term important and short-term not so important.
And I agree with you, and I think certainly in business decision-making, you know, the business leaders are not going to make decisions based on simply, you know, what comes out of a machine learning algorithm.
That's precisely the issue. I come from industry where people are looking for indicators, and they'll jump on them because they think they're going to be successful by going in quickly. But as I'm actually at MIT when we're looking at using things like Data Wrangler, we find your intuition into the data the machine's intuition into the data is often not correct.
Which is why I'm very interested in this area of helping guide an analyst or a decision maker through the data and pointing out maybe anomalies or interesting areas of interest that deserve a deeper dive so that they can start to understand why, and maybe it turns out that what they're seeing is due to some something that happened that's entirely disconnected from their intuition.
Yeah, I just agree that it's an important challenge. In fact, what I teach students in my class is always start with the guiding question. Like, before you look at the data, even though your question can be wrong, and that's fine, you learn a lot from that in the process, but really basically the seeds of what later become more formal hypotheses, whether it's, have masses of data or a small amount of data, I don't think the process should be fundamentally different in that regard. I do think it's interesting to think about how our tools bias us to certain ways of thinking. And so certainly there are certain statistical tools that will give you back, things that you can begin to interpret as explanatory in terms of, say, like your regression coefficients, et cetera, and what those represent. Many machine learning algorithms can make that more difficult, and that's not necessarily their fault, and that they weren't necessarily designed for that, but this predictive versus explanatory trade-off is one that we certainly see play out between statisticians and machine learning researchers. And so I think one interesting question is, well, even if it's for more casual, even to business users, et cetera, how do our tools promote skepticism is maybe one starting point to get at the larger issue that you raise. Especially, one point I would just call it seems that we're very driven towards positives. What I mean by that is whether it's a true positive or a false positive, we want to find the thing. And very rarely do our visualization tools, for example, say, what would this look like if it is truly random? And show me a bunch of examples of that, because obviously our own perception understanding of what randomness means is pretty wrong most of the time. But our tools could actually help with that, and so it's interesting if we start with those types of questions, how does that open up new design possibilities that may help at least nudge us in a more productive direction?
I'd like to add that I think we're in a period of a little bit of infatuation. A lot of this is new, and a lot of the examples that are of practical use of these tools are very impressive. It's true that the results are very impressive, so I think there's a period of somewhat we're just sort of blinded by the shiny. But even in the research community, there's beginning efforts to ask some of these questions, and I know that a lot of machine learning researchers are trying to say, well, let's try to actually dig back into these enormously complex million parameter models and try to find ways of building interpretability out of of them and connecting them back to predictive models and connecting them back, even if we build these massive statistical machines, how can we extract kind of digestible insight out of them rather than simply, well, the predictions work because the black box does what it does, and when it doesn't work, we don't know why either, right? And so I think the machine learning community is beginning to enter a phase where they're starting to ask those questions in a serious and systematic way. It's a brutally difficult problem, but I think it's a problem that will be tackled in the next decade once some of the infatuation with simply, wow, the machines work, fades out. And I hope that critical era will actually come.
And I think also starting to enable decision makers to say, well, if I had used this slightly different model, how would it have impacted how would it impact the decision I make, and allowing them to explore those kind of scenarios as opposed to providing them the output of an optimization model that's based on one specific data-driven probability distribution estimate that goes into the optimization.
Yeah, and I would add that businesses are starting to hire executives in the data function. So like in the past, I'd say that the data people are often sort of in the corner, sort of doing their analysis on their own and not really part of the key decision making. And there's a trend now where data scientists are in executive positions, and so they're there to sort of help moderate the discussion, I suppose, and be more skeptical and also ask the questions that you're concerned with.
So when I was handed the mic, I was actually trying to ask what Rachel may have already gotten to. I heard a lot of the conversation being about how do we communicate the results to the person who then does the right thing with it. And I think there is the second side to it that is, as a data scientist, I found actually more rewarding. I need to make the decision maker understand what kind of problems he can be asking about and what the opportunities even are. I have to shape where the question is going. I can't be handed a question and then only have to worry how to frame the answer. I have to be part of that executive debate and even in educating the management level of what can and cannot be done with data, even in the best case scenario. And I would like to have maybe you comment on that side.
I think that's a very important point. One way that we have addressed that at IBM is we actually have an internal consulting group that serves as a bridge between sort of the executive leadership and the researchers. So these are people who have some amount of quantitative training, maybe at an MBA level, but they can't perform the deep technical work that the researchers do, but they can bridge between sort of the decision makers at the executive level and what the researcher is actually doing, and trying to help get the right message across and help shape the direction that the problem is and how it's being defined.
Hi. Is there? Okay. So several steps in the data science process, particularly choosing a visualization or building a model, it's very ad hoc, or there's some black art to it. So there's some creativity involved. There's a very large space you're trying to explore. How much of it do you think can be automated? Because there are a lot of options. There has to be feature selection and so on. Do you think tools can really help there, or you are going to need sort of human in the loop involved constantly?
I want to address that just because I was thinking about IPython. I find that very compelling, and I was thinking of how that you can start to have repositories or just availability of notebooks that can be rated, I guess, and recommended and start to serve as guides to a new data scientist as to, well, this analysis process is really the one that is used by many of the top data scientists to address this type of problem for this type of data, and start to educate people in that way.
I agree. I think
whether it's IPython notebooks or something else, something that allows us to scale up forms of apprenticeship learning is an interesting idea. But I'd also challenge one part of your question. I don't think the process is completely ad hoc. At least it may be something that people have to learn, and there is randomness and exploration within it. But for both modeling and visualization, we clearly have a really nice base of theory. And I think those are the important foundational classes that you should get if, for example, if you put out a data science program. Within visualization, for example, we have a pretty good understanding. It's far from complete, but good enough to operationalize, including automated design algorithms that say, given certain data types or their combinations, what forms of visual variable will be most effective for people being to quickly and accurately decode the information. And there's, it's an active area of research, but we also know enough to begin to act on it with some confidence. Similarly, you don't just pick a model out of the blue based on the types of inputs and outputs you want in your tasks. You'll pick that. Now, the real experts know something else too, whether it's about the geometry of their feature space or other things, where they're going to have a very well-honed intuition as to what types of models work best. And I think finding better ways to kind of encapsulate, or really write down and articulate those types of knowledges, whether that's in the form of notebooks, I'm not sure, because that's more of a residue of the process. You don't necessarily see what's going on in the person's mind. But understanding how we bring those into the educational process, I think, is valuable, and it moves it from so it's a view of an ad hoc process to one that actually has a lot of structure, even though there is randomness and exploration inherent in it.
One thing that we're seeing with IPython is actually the sharing of these. We have on our website, if you click on a link that takes to a gallery, there's a gallery that lists collections of interesting notebooks on topics, and we're seeing kind of the creation of these topical notebook groups that address these kinds of issues. But one of the reasons why we've taken this approach and we're spending so much time on this is precisely going back to what Jeff said about skepticism in our tools, is that precisely one reason I like this approach is that even though we can annotate it, when the user grabs that tool and starts using it, they're still in control. It is not meant to be a black box where you put an input and you push a button and the whole thing runs to the end. At every step of the way, yes, you can say run all, and you can change maybe the file name at the top and say run all, and the thing will run to the bottom. But every step of the way, the box is not black. The box is open, it's transparent. Each of those things allows you to go and type into it, because we really want to encourage the notion of an informed and skeptical user who always has access to the underlying tools, to exploring the parameters, to changing the algorithms, and the ability to annotate those decisions by putting narrative text along with it. So, so that this idea of a very skeptical, inquisitive analyst is always at the center, and we're really trying to shy away from the idea that this can be automated from one end to the other and turned into a black box with a big green button in the front, kind of the publish on nature button.
So let's take one more question, the last question.
So this is a question about product development and old and new media culture for Rachel, but maybe some of the other panelists have some insight. And forgive me as I kind of puzzle out my question, but so it's about disruption and product development. So in the film industry, because I'm an industry practitioner, we had a data science disruption with computer graphics, where if you look at the computer graphics from Star Wars Episode 4 through the current Harry Potter films, I mean, you can just kind of put whatever X on, the 1000X on the data science of that information processing, from capture through output, digital distribution, nonlinear editing. And so what the film industry did well was keep practitioners in the workflow discussion and leverage institutional knowledge. And I think about your position, and I think about a decimated newsroom, and they're kind of vulnerable. And you guys are coming in with all this headline news. And I can't think of a more challenging climate for trying to keep the practitioners and the institutional knowledge and respect the way the newsroom thinks and get it into the product development, because Scrum and A/B testing isn't accessible to creative practitioners. So they might shut down on you. And I'm facing similar challenges in the television disruption space. What is News Corp? What are you doing? And I know you're only in 3 months. This is probably problem number one for you. But how are you creating a collaborative culture across left brain, right brain, different institutional skill sets to bring the data scientists together with the other creative professionals and the journalists?
Yeah, I mean, that's a tough question. first of all, I don't think that data science can solve every problem, so I don't come in with that attitude. I have a tremendous respect for the creative professionals. They are the intellectual, a large portion of the intellectual talent at our organization. So it's not, my job to completely disrupt them. It's more a matter of trying to collaborate with them and build interdisciplinary teams that do include them. I have conversations from like all levels of people, with the editors, with the journalists, with the data journalists. And so it's not like I'm coming in to disrupt and say data is going to completely change the newsroom and we're going to change the way we're doing things around here. Rather, I'm trying to find ways to help them do their jobs better if they want. And there's definitely around the businesses a demand for more data. They're asking, in many cases, they're asking for help. So it's not sort of this top-down, we're coming in to disrupt. Rather, it's like bottom-up. People are asking for more help with how they can use data better to do their jobs. But I do consider it a collaborative effort, and I would never just have data scientists in isolation working to solve problems and then imposing them on other people who don't want them.
All right, well, with this, let's thank all of the speakers again.